Okay, I'm at True Team today, so I'm picking up where I left off. So I'm going to go over problem. I did 7 yesterday, so 7's done now. I'm going through all these problems that we've been doing. I'll go to problem 8 real quick, and then I'm also going to do problem 19 today because I want to get that taken care of, the word problem. So problem 8 is 4x over x squared minus 4. Okay, it's f of x equals 4x over x squared minus 4. Now, the first step is to simplify it, if you can. So we got 4x over x minus 2, x plus 2. Okay, now nothing cancels, so your domain is just going to be x cannot equal plus or minus 2. And even if it did cancel, you still have to exclude that from the domain. So there's my domain. Now, these can either be classified as wholes or vertical asymptotes. We know they're VAs because it didn't cancel, so we're going to have VAs at x equals plus or minus 2. Wholes, none. And then we go to HA and slant. All right, let's go back through the rules for HA and slant. Okay, let's look at the powers. The highest power on top is 4x to the first. I'll circle it in blue. Highest power on bottom, it's bottom heavy, so it's y equals 0. And there's no slant. Okay, now we have zeros. X-intercepts, that's where the top equals 0, so you just take the top, set it equal to 0, and you get x equals 0, so that gives you 0, 0, because remember we're setting f of x equal to 0. We're letting y equal 0. Now, if 0, 0 is the 0, it's also the y-intercept. You don't even have to do that one, because that's when x is 0. Well, we already know what x is when x is 0. It's 0, 0. All right, sign analysis. Remember, the only thing you can use in your sign analysis is whatever causes interruptions in the x-axis. So I'm going to circle that in green. So that would be VAs. It's always VAs and zeros. So right there. So we have plus or minus 2 and 0. So my sign analysis for number 8 is going to be negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. Okay, then I'll do my test values. I'm going to test 1 because x equals 1 fits in this interval. I can't do 0 because 0 is a part of the sign analysis. So I'm going to test 1. I always test in the factored version because I think it's easier because you put 1 on top, it makes it positive. To get a positive, 1 here will make it negative, 1 here will make it positive. So you have a positive divided by negative times a positive, which is a negative. So a positive divided by negative is a negative. Signs will alternate. All right. So now what we're going to do, we're going to graph. The easiest way to graph this, okay, is plot your point, 0, 0. Okay, done. Plotted that. Same thing as the y-intercept. Horizontal asymptotes, y equals 0, so there's nothing special there. That's just the x-axis is serving as the horizontal asymptote. We do have vertical asymptotes of plus or minus 2. And then we know that the graph is below, so it's going to be here. And then the graph's above, and then it's below, and then it's above. So that's what that graph would look like. We already stated the domain. You can state the range on this one. The range, it does go, this graph goes down forever, and it does go up forever. It goes up here, it goes down here. Some people would say it doesn't hit 0, but it does cross through 0 here in the middle, so the range is all real numbers. Not that, I haven't really made a big deal. Sometimes I'll make you find the range. If I'm going to ask for the range, I'll make sure you can do it without a calculator. Now let's go back to do, so number 8 is done now. So we're getting all these done. We've got 10, 13, 16, 17, and 15 left to do. I'm going to go and do 19 now. And I'm going to erase the work that I have here from the other day so that you can see me do 19 right here. Okay, so that's Friday's work. Let me get rid of that. Okay, number 19. Let's get this one checked off here. The cost, C in dollars, to remove P% of the invasive species of some kind of fish. I don't even know what this is. Ipazuti fish fish from Sasquatch Pond is given by C of P is equal to 1700 P divided by 100 minus P. And P is defined, the domain, they're telling us the domain is between 0 and 100. So they've limited the domain to 0 to 100. So in other words, the percent of these fish is from 0 to 100%. That makes sense. We're not going to go above 100%, and we're not going to go into negative percents. Find and interpret C of 25 and C of 95. C of 25 would just be plug 25 in. So it's going to be 1700, plugging in 25%, and divided by 100 minus 25. So I want to see here. I just want to look here in the answer key if they're wanting us to. Let's go have a look here. As we do this one, let's go back. This is 4.1. I want to go back and look at the answers to 4.1 on this one, number 19, because I want to make sure that this percent for number 19. Let's look at it real quick. Answer. Sure, when they're plugging in 19. Okay, yeah, they're plugging in 25. So you're going to get 590. So let's see here. If I type this in on the calculator, so let's go back to this. If I use my calculator, I'll split my screen so you can see this. Let's see here. Add another window. Where's my calculator at? Let's see here. Well, there we go. Got it. So we go to a home screen. I'm going to type this in. Let's see. I've got, let's see, what do I got? 1700 alpha x. I got 1700 times 25 divided by 100 minus 25. Hit enter. That gives me, is that right? Is it 100 minus 25? 1700 times 25. That gives me, did I write that down? It's 1770. My fault. 1770. That'll be better. Okay, now it'll work. So let's go back and fix that. I can just copy and paste that again. Let's go up there and change that to, let's see, can I get in there? 1770. There, 590. So this would be 590. So what this means is it's going to cost us $590 to remove 25% of the fish. $500 to remove 25% of these fish. The Ippazuti fish, I guess, in Sasquatch Pond. Now we go to C of 95. So to get 95% of the fish gone, to remove these bad fish, I guess. I don't know what they do. Maybe they eat up everything. We're going to do the same thing. Now, what you could do is you could copy and paste and change this again, but you could type the original equation into the y equals, if you want 1770x divided by, and I'd have to put 100 minus x in the denominator in parentheses. Unless you use alpha x, then you don't have to do that. You could type in the equation 1770x divided by 100 minus x, and you could go to the table. And then what you could do in the table is just go down until you get down to 25%. There's your 590. And then you could go down to 95%. Now, a quick way to scroll down, if you press second window, you can change your table start to what you want it to be. So now I can just go down to 95, and it's going to be, wow, that's a lot of money to remove. So it's $33,630. $33,630 to remove 95% of the fish. Okay. What does the vertical asymptote at x equals 100 mean in context of the problem? Okay, I'm just going to go and cheat and kind of look at the answer key here just to speed this up. So C of 25 was 590. Okay, you're looking at it right here. 590 to remove 25% of the fish, and C of 95 was 33,630, means it costs $33,630 to remove 95% of the fish. Part B, the vertical asymptote at x equals 100 means that if we try to remove 100% of the fish from the pond, the cost will increase without bound because it's impossible to remove all the fish. I mean, it's just going to get too expensive to try and remove all the fish, because you're going to get down to a point where, yeah, it's just going to shoot up. It's going to cost so much money. And then if you had $40,000, you could remove about 95.76% of the fish. Let me show you how you can solve that one. So part C, what you could do there is take the equation, and you want to know what percentage with $40,000 you would set the equation equal to 40,000. So you'd actually take and set the cost. So part C, you would go 40,000 is equal to 1770p over 100 minus p. So what you would do is you'd multiply both sides by the denominator to get the variable out of the denominator. So I'd multiply both sides by 100 minus p. 100 minus p. And then you're going to have 40,000, I guess it's $40,000, times 100 minus p is equal to 1770p. So then you'll get, you'll add 2 zeros, 1, 2, 1, 2, 3. So I added 2 zeros. So now you've got 4 million, because you added 2 more zeros, minus 40,000p equals 1770p. So then I'd add the 40,000p to the other side, so I have 4 million is equal to 41,770p. Divide by this, and then we'll see what P equals, and that would tell me the percentage that you could remove if you had $40,000 budget. So I'm going to take, let's see, 4 million, go to the home screen, 4 million, divided by, what was it, 41,770. And you get like 95.76%. I think that's what it had. Let's see. Yep, 95.76% of the fish get removed for $40,000. So there's a couple homework problems done for you. All right, now we're going to go back I'm going to remove this screen now. Let's go back to a full screen mode. Okay, let's go back to where we left off yesterday, and I'm going to finish up 4.2 today and hopefully get 4.3 started. Yesterday I left off on this problem, and I believe it is on page, I'm going to go back to, let's see here, 4.3. 4.2, it's on page 328. So if you go back to page 328, we're looking at this problem, and I messed it up yesterday, which is good because I forgot to video this part. So if you see on page, we're on page 328, we're looking at example 4.2.3. So example 4.2.3 on page 328. All right, we're going to go through the whole process of here. First thing you're going to want to do is factor this. The thing we got into yesterday is the bottom is easy to factor. That factors into x. I think I wrote this down right. That's a plus 3x. Hold on. Let's get the equation written down right before I start. Let's make sure I got everything written down. X squared plus 3x plus 2. All right, here we go. So this right here is going to factor into x plus 2, x plus 1. All right, this right here, we're going to have to use synthetic division for. So we did this yesterday, but what you would do is you would do your P is 1, and you would do your Q is 2. So your P is plus or minus 1, your Q is plus or minus 1 and plus or minus 2. So your P over Q would be plus or minus 1 and plus or minus 1/2. So we know these are the only 4 things you would try in synthetic division. So let's try, and I think we did -1. We tried this yesterday, but we stopped because we ran out of time, and I goofed something up. So drop a 2, we get a -2, we get a 3, we get a -3, we get a 1, get a -1, and that gives me a remainder of 0. So that means x plus 1 factored out of it, times 2x squared is what's left, plus 3x plus 1. You can slide and glide this if you want. That's x squared plus 3x plus 2. And so then that will factor down to x plus 1 times x plus 2 and x plus 1. And then since you slid the 2, you need to divide by the 2. Over x plus 2 times x plus 1. So the factored version of this, now you get one of the x plus 1s to cancel. Now that's still going to be, and I'll get to the domain here in a second, but you still have an x plus 1 left on top, so that's interesting. We haven't had that happen before. Or we did once on Friday. I should take that back. So your whole is going to cancel. There's going to be a hole at -1, but there's still going to be an x plus 1 left on top because we didn't cancel both of them out. This one's going to be 2x plus 1 when you glide the 2 out front over x plus 2. Now, this is the simplified version of the equation. I'm going to block this off because I do have a hole, and this is what you plug into to locate the hole. Now, let's go through it. First of all, I'm going to put stuff in black here. Domain. X cannot equal -2, but it also can't equal -1 because that is an undefined value. So this is the domain. Now, the -2 is a VA. Okay? The hole is x equals -1. Now, that's where it's located. But to figure out the point for the hole, like where to plot the point, you need the x and the y. To get the y, you plug into the simplified version, not this version up here, because if you plug into this version, you're going to get a 0 here and a 0 here, and you can't have 0 in the denominator. So we got to plug into the version where the x plus 1 is not in the denominator. So we're plugging into the simplified equation so we do not be stupefied. Okay, so we're going to plug -1 in. So that'll give me -1 plus 1. Ooh, that's interesting because I have an x plus 1 left on top. We are going to get a 0 on top, which is okay. 2 times -1 plus 1 over -1 plus 2. -1 plus 2. So you get 0 times, that'll be -2 plus 1, which is -1, over 1. 0 times anything is 0. 0 divided by anything is 0. So you're going to get the hole is located at -1, 0, which is interesting because this is on the x-axis. So that hole is actually located on the x-axis. Now, it technically is not an x-intercept, but it does disrupt the x-axis. And if you disrupt the x-axis, like if you think about it, if you have -1, 0, you could go through that hole, skip over it, and then go from below to above, or you can go from above to below. So a hole does matter. All right, now let's do HAs and slant. Let's see, go back to the original equation for this. It looks like it is top heavy, so that means it is no HA, but there's going to be a slant. And to do the slant, we're going to use, you could do the long division with the original, or you can use the simplified version with synthetic. But if you do synthetic with the simplified, you're going to put -2 in the box, which is what I'm going to do. But this top part has to be multiplied out. Well, we know what that is because we factored it. It's right there. Okay? So that's going to be, we're taking the simplified equation and we're doing synthetic division. So we get a 2, a 3, and a 1 from this right there, divided by x plus 2. So drop the 2, get a -4, you get a -1, you get a +2, you get a remainder of 3. The remainder doesn't matter because all we care about is this. So our slant asymptote is 2x minus 1. Last thing, zeros and y-intercept. Zeros. Zeros is where the top equals 0. So go back to the simplified equation right there. I know it's hard to see because I'm marking up. I'll do it in green now. So you get 0 at x equals -1. Well, that really is not a 0. It's a hole. But we're going to let it act like a 0 even though there's nothing there. And then we're going to have x equals -1/2. So you've got -1, 0 is a hole. So yes, it's a 0 because it's on the x-axis, but it's not really there. And then -1/2, 0. So we're going to use our zeros and our VA to do our sign analysis here in a second. Now y-intercepts, let's do that real quick. Y-intercept is what you get if you plug 0 in. I plug it into, you could plug into the original, or you can plug into the simplified over here. But if you do the original, everything will 0 out when you plug 0 in, except for the 1 and the 2, so you get 1/2. 0, 1/2. Okay, so that's kind of nice. Now, my sign analysis. Here we go. I'm going to use the VA and the 0. So we're going to have negative infinity to -2, I believe. -2 to -1. -1 to -1/2. And then -1/2 to infinity.
No, that's not it.
So now I need a test. Let's test. I can test 0. Sweet. So I'm going to use the simplified. It's easier. That's going to be a positive. That's going to be a positive. That's going to be a positive. A positive divided times a positive divided by positive is a positive. So it will alternate signs because there's no multiplicity 2. So here's how it's going to start. And I tried to graph this earlier today, and I'm going to kind of make sure I've got this right. I'm going to restart it here. So see here, let's get everything you've got plotted. I'm hoping I did this right now. Okay, I'm going to be very careful when I graph this. So we have a VA at -2. So let's go to -2. We have a VA. We have a hole at -1. So there's the hole there at -1, 0. We have another x-intercept at -1/2. And then we have a y-intercept at 1/2, positive 1/2. Okay? And then we have a slant. Let's see what I was thinking a second here. No HA, and then we got a slant, 2x minus 1. That slant's going to have a y-intercept of -1, and then it's going to go up to, so it's down there, up to right 1, down to 1, 2, left 1, and then draw your slant. And you got to be very careful when you're drawing your slant in because you want it in a perfect spot. Okay. I'm thinking I'm getting this time. So my graph starts below. So that's, oh, that would, yep, I did have it wrong earlier. So when it's below, it's got to be here. It's got to approach that slant and approach that vertical asymptote. Okay. Then it's going to be above. So it's going to go here. And then it's going to dip. So we got below, above. Then it's going to dip below for just a little bit. And then it goes above, and it's going to have to go towards the slant asymptote. So there it is. That's way better. Now, the range would be really difficult to find because the range would be predicated on can you figure out what this bottom is and can you figure out what this top is. And then it would be something like this, negative infinity up to whatever this top is. Like you would have to figure out what that y value is, union. Then you'd have to figure out how low this goes. So that number, whatever that number is, to infinity. I'm not going to make you do that without a calculator. But that's what that graph looks like with the hole. So a really good example. Okay, moving on. I think we're getting close here. Yep, and there's the graph. Yeah, so 4 point. And it was just, I don't know if you can tell, but it barely went below. Theirs is a little bit better than mine, but we get the idea. One other thing that I'll make a comment about is on the VAs. We talked about this in class. It's kind of the extra credit and the slant. When we do the VAs, like so at x equals -2, remember I told you, you can take the simplified equation, which was x plus 1 times 2x plus 1 over x plus 2, I believe it is. Yeah, I think that's it. Except for, yeah, it's x plus 1, 2x. Yep, that's it. And then what you can do is you can do the limit of that. And what we know is the limit as x approaches -2 from the left of this thing, x plus 1 times 2x plus 1 over x plus 2. We know the limit of that as you approach that VA at -2. We know that it's going down. We know that because that VA here, it's going down to negative infinity. And then if you do the limit as x approaches negative 2 from the right of x plus 1 times 2x plus 1 over x plus 2, we know from the right side of negative 2, we're going to positive infinity. And then when you do the tails, I'll do those in red. This is extra credit. You don't have to, you're not required to do this as extra credit if you do these. The tails, the slant or the HA, you would do the limit as x approaches infinity and negative infinity, but they're going to be the same thing. Okay. So this one, you have the x plus 1 times 2x plus 1 over x plus 2. And what it approaches either the HA, which is a number, or in this case, it approaches 2x minus 1. It approaches that slant asymptote. Same thing here for the left tail. It's going to approach that slant asymptote, which is 2x minus 1. Okay, it actually approaches that slant asymptote. So anyways, that is 4.2 done. Starting 4.3. 4.3 is more, has nothing to do with graphing. It has everything to do with solving equations and inequalities involving rational functions, explore rational inequalities. So a couple things. Next example showcases critical differences in procedures between solving a rational equation and rational inequality. So let's start with rational equations. Okay, if you're doing a rational equation, you're trying to figure out where this graph actually equals this graph. So I'm going to show you. On part B, you're trying to figure out where this graph is greater than this graph. So I'm going to take this, I'm going to plug it into the calculator, so I'm going to split my screen again. So let's go back to the calculator. Let's split the screen, add another window. Here we go. I'm going to add this one. So I'm going to type those equations in. So I'm going to go to y equals, first one, alpha x. We've got x to the third minus 2x. We got x to the third. Please do this with me. Minus 2x. And then I think it's plus 1. Yep. And then over x minus 1. And then what I'm going to do is I'm going to put so this one's going in y1. I'm going to put this one in y2. So now we got 1/2 x minus 1. 1 divided by 2, x minus 1. I'm going to zoom 6 it to reset my window. There, we got it. All right. So this is what we have. We have a graph that looks something like this. Now, if I zoom in on it, you'll see where they're equal, where they cross. So the first statement, where they're equal, I'm figuring out where they intersect. Where do they intersect? And we're going to learn how to do this by hand. I'm going to show you first how to do it with the calculator. So where do they intersect? Well, we can do second trace, and we can do option 5. Everybody see it? It's right here. Option 5 intersects. So I went second trace. I chose option 5. And then what I can do is I can move my cursor. It's really hard to see where it is right now, so let me see here. I gotta see the buttons just a little bit. Okay, at the bottom of the screen, it kind of tells me where it's at. Looks like I'm going the wrong way, so let's see here. Come on, come positive, come positive, come positive. There it is. So you find that cursor, and I'm gonna do the first one. It's gonna ask me, yours will say first curve, mine says left bound, but on the graphing calculators it says first curve. Since I got to do a left bound, I got to be a little bit to the left, and then I'm going to be a little bit to the right. Yours does first curve, second curve, guess, but you're going to get negative 0.5, negative 1.25. So negative 1/2 and negative 1.25, which is, so that would be, so this is negative 0.5, and then, or you could have negative 1/2, negative 5/4. So the first x value, it says solve this equation, so we're solving for x, is just x equals negative 1/2. That's the first x value, because we're solving for x. Now the y value is important too, but they're only wanting you to solve for the x in the equation. The next part would be you would have to go do this one over here. So I'd have to move over here, scroll over and get this point. So I'm going to do second trace again, do intersect 5. I'm going to go over here and do this one where they cross. I'm going to do, yours will say first curve, second curve, guess. So you just put it really close. You don't have to worry about if you're to the right or left. And I'm going to get 0, -1. So I get 0, -1. So the x value is 0. So there's two solutions to this. So for this first one, when you figured out where this equation equals this equation, they equal each other at -1/2 and at 0. So part A, the solutions are x equals -1/2 and 0. And all I did was figure out where they intersect. It should say intersect. I don't know why I put intercept. Same thing, where they intercept each other, like a touchdown intercept or a interception in football. Okay, now, so that's the answer for part A. Now, that answer from part A can actually be used in part B, because in part B, what you're trying to do is figure out this equation, which we put in y1, when is it greater than or equal to the line? Okay, when is it greater than or equal to y2? So when is it above it? Because we're talking about the y, so when is it above it? Well, these points come in handy now, because I know that this parabola-looking thing, okay, it kind of looks like a parabola. Now, I don't know if that's totally what it looks like, but that appears to be what it is. When is the parabola-looking thing bigger than the line? Well, we know we crossed here at -1/2 and 0. So this part right here is where the blue one is bigger than the red one. This part, the red one's bigger, and then this part, the blue one's bigger. So I would say the blue one is bigger from -infinity. Now watch. Okay, the blue one is, sorry, I keep moving off that. The blue one is bigger from -infinity up to -1/2. And then from -1/2 to 0, the red one's bigger. And then you get here, the blue one's bigger again from 0 to infinity. So the question is when is the blue one, the y1 equation, which is this complicated looking thing. And the reason this is a parabola, if you take x cubed divided by x, you're going to get an x squared. So that's why it ends up being a parabola. There must be a hole in the parabola. And I don't think it's too hard to see that. Like, we just got done doing that. Now remember, we put this one into y1, we put this into y2, and y2 is the red one. So let me put that in red so you can just keep it straight. But this one right here, this is a line. The red one's obviously a line. The blue one is a parabola. Why is it a parabola? Because I bet the top 1 would work with synthetic division. So you get a 1, a 0, a -2, and a 1. Drop the 1, you get a 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 -1, you get a -1. Oh, remainder 0. So x minus 1 actually factors into that. So if you factored this, you would have x minus 1 times x squared plus x minus 1 over x minus 1. So what you end up with is a parabola with a hole at 1. Hole at 1, comma. If you plugged 1 in, you would get 1 plus 1 minus 1, which would be 2 minus 1, which is 1. I bet if I go on the graph of this parabola, if I go to the table, second graph, and I go to 1, let me go back to 1. That's going to take me forever. Let me go second window and start my table, start at 1. Okay, if I go back to 1, notice, look, you see an error on the blue one because there's a hole there. So 1, you won't see it here. Oh, they do show it on mine. You can kind of see, let's see. Yep, you can see there's just a very faint hole there at 1. It's at 1, 1. But anyways, not that you really need to know that, but it's pretty interesting. So I know the blue graph was greater than the red graph from -infinity to -1/2, and that's why these points of intersection were important, union, and then 0 to infinity. Now, so this is if y1 is greater than or equal to, so that's part B. If you would have wanted it the other way, let's do a part C. If you wanted to know where y1 was less than or equal to y2, then it would have been from negative 1/2 to 0, because that's when the red graph was bigger. So that kind of gives you an idea of what we're talking about here. I'm going to enter full screen again. And I know we're getting close here. So let's go here. So that's essentially what's happening now. How do we do this by hand? Well, to do this by hand, what we're going to do is we're going to do some algebra. So what we're going to do is we're going to take x to the third minus 2x plus 1. I showed you how to do it with a calculator. You just see where they cross. But if you want to do it by hand, what you have to do is you have to get rid of the denominator. You can't have x in the denominator, so you multiply both sides by x minus 1. Now, here's the thing you have to keep track of, is we know the domain x cannot equal 1 because that would give us 0 in the denominator. So you have to keep that in mind, that you are not allowed to have any solutions where x equals 1. So I would always, before I even start solving equations, if there's denominators, you need to make sure you specify the domain so that if that shows up as a solution, you cross it out because x is not allowed to equal that. But anyways, we're going to get rid of that denominator. So we multiply both sides by x minus 1. Then we're going to get x to the third minus 2x plus 1 equals, I'll FOIL this, that'll give me a 1/2 x squared minus a 1/2 x minus an x plus a 1. Now, since it's got x cubes and x squareds and x, we're going to set it equal to 0 and see if we can factor. So I'm going to move everything to the x cubed side. So we're going to go x cubed. That's taken care of. I'm going to move the 1/2 x squared over. So I subtracted it. And then I've got a negative 1/2 minus x, which is going to give me, if I do that there, that's a minus 3/2 x. Because there's a 1 in front of here, which is really 2 over 2. If you want to think of it like that, it's minus 2 over 2. So that, if I add 3/2 x to the other side, I got to think of 2 as 4 over 2. So it's negative 4 over 2 plus 3 over 2, which is negative 1/2 x. Okay, so that's all good. Got that taken care of. Now, I move the 1 over, minus the 1. That's going to cancel the 1, so we get equals 0. Well, that's good news, because now I can factor an x out. So we get x squared minus 1/2 x minus 1/2. Now, a lot of people do not like the fact that there is fractions here. So I'll set that equal to 0, and I'll tell you what you can do. But you're going to get one answer as x equals 0. Okay, that'll come from that, which we already found. We knew it was 0. Remember, we went up here and did this. We said one of the answers was going to be 0. The other one's going to be negative 1/2. Let's see how we get that. You can try and factor this if you want. Find the factors of negative 1/2 that'll add up to get negative 1/2, which is going to be obviously negative 1/2 and 1. Let's just do it. It's not that hard. What are the factors of negative 1/2 that'll add up to give you negative 1/2? Well, it'd be 1/2 and 1. So it'd have to be a minus 1 and a plus 1/2. So let's see. If you FOIL that, you'll get, let's check it. You'll get x squared. You'll get plus 1/2 x minus 1x, which will give minus 1/2 x. And then you'll get the minus 1/2. So yes, this FOILs. So you get two solutions. You get x equals 1, and you get x equals negative 1/2. But remember what we said. X cannot equal 1. So we have to throw that solution out. So then the answer is 0 and negative 1/2, which is the same thing we got with the calculator. And they did all that, and then they, obviously, I don't think they did a good job because they should throw out the 1. Oh yeah, check, x equals 1 does not satisfy the original solution, so it's negative 1/2 and 0. Now, once you get that done, part B is simple, because then what you do to solve part B is once you get your x-intercepts of x equals negative 1/2 and 0, okay, and then your domain x cannot equal 1, Okay. What you do is you end up just doing a sign diagram, and we're going to talk about that on Wednesday. So I'm going to wait till Wednesday to finish that up with the sign diagram, because that'll go a lot better when I'm here. Let's see. I think that's going to be, let me just make sure. I just want to make sure we've got everything. Yep, and that will be all of, we've just got this, do the sign diagram and do a word problem on Wednesday, and then we've got it all. So, yeah, we'll see you Wednesday.